Here the first question will be, what do you mean by object oriented programming? See, there are different types of programming types: structure oriented programming, functional programming, and object oriented programming. And one striking ability of the object oriented programming is that it is very well related to the real time objects, real time scenario, because in real time we are dealing with peoples. Then the second level only we are going with the data. So all the data that we handle in the real time is related with any of the people, any of the things, any of the objects. So that is the same thing which has been inspired by the computer scientists and created a new object oriented programming approach. In this approach, all the data were related to some other people. So not even a single data has been fetched directly, or you can allow to manipulate directly. So one all the communications, all the manipulation has been done only through the objects. So OOPS implements real world entities like inheritance, polymorphism, and all the other things like hiding, abstraction. So here all the communications to the data has been communicated by methods which is present inside a class, and those methods were accessed only with the help of the objects. Every time every new object goes and access the data, they have their own copy and they have their own memory. They have individual memory, like as we all have our own stuff in real time, likewise every individual object has its own trace of memory. All the objects has its independent memory, and data will be stored in their independent memory. Whatever the change I'm done using in my object will not be reflected in the other object. So everything is protected in terms of objects. So what are the features of object-oriented programming that makes us to use Python as an object-oriented programming? And Python is one of the pure object-oriented language. It deals everything as objects only. You could have been remember that the way before we discussed in the video 1 and 2 about data types. I said all the data were treated as objects only, even though we are trying to display the type of the data by using a type function. It will be displayed as class strings, class int only, which means that we are dealing with objects. So why object oriented programming has this much of impact in it? The code can be reused through inheritance, thereby reducing redundancy. Once you written a code, as time progresses there will be some additional you can add something into the development code, or you can reduce something, you can delete some features. So with respect, as the time progresses, there might be some changes to be inculcated in the software model we already have. If it is not an object oriented programming, we have to rewrite the code. If it is an object oriented programming, we take that as a base model and we build on the model, and this is called inheritance. That is one of the most striking feature of any object oriented language. And another thing is that it gives a layer of security. Just consider that in a room, in a room you put all your stuff without any protection. Just throw your data inside a RAM, anyone can come and access it. So there is no protection in it, right? Anyone can access and anyone can manipulate it. But in real time we used to have some protection, some sort of protection for our own data. So we achieved that by using encapsulation. Here all the data were encapsulated. Class is only having what are the types of data I'm going to use and what I'm going to do use. So only the instructions. All the data were stored in my own memory. As we said before, every object has its own memory. So I take my memory and call the methods to do a task and take the result and store in my area. And some 100 objects came. 100 object has their own memory and do all those processes and keep their results on their own. So whenever I wanted to know the results of some object 10 or object 11, I need to call the object 11, please give me a result. Then only I can get to know what is the result he is having. So that is a kind of encapsulation of security that is provided using encapsulation. And it also gives us data hiding. No one knows what is there inside a class. So literally no one knows. Only the object can access, even though objects can access the data members through the methods inside the class only. That is the correct way of accessing it. You have to call the method. The method only has to access those data. So you can now see the way we are handling the data, which is more procedural. It has more sense to it, so. And the polymorphism is that we write a single code and it behaves differently for different kinds of inputs, and that can be achieved by using lambda function also to a certain extent. So that is all with OOPS. So the next important question is, what is the difference between object and class, or what is an object and what is a class? See, I can say class as an user defined data type. You are designing your data type. Just consider that your ID card. What are the data available in your ID card? There will be a photograph, there will be an address, there will be some signature, there will be some phone number, there will be some room number, some city, some pin codes. All are different kinds of data, likewise, when in real time, whenever we are about to deal with different kinds of data put together, and we wanted to treat it as a single entity, not a single data member, single entity, so there we can go with class and objects. So I'm designing, this is a kind of an object. It is like that drawing a person. So these are the features that this object has. These are the abilities of the feature, or the features that the particular entity is having. Let us consider a car. I'm describing how a car looks like, and I'm telling what are the functions or tasks that can be performed by the car. This is called a class, right? So I'm telling two things, what it is and what it is capable of. So in terms of data and in terms of methods. So methods always tells about the abilities of the entity, and the data tells about the entity itself, right? And what is objects here? So objects are the real world entity. So I described, this is how the car would be. It has some four wheels, it has a steering wheel, horn, lights, switches, and all such things, no? Then I'm going to say there are different types of cars. So Suzuki is a car, some Hyundai. So there are different types of cars. So they were real time objects. Which are the objects that matches with these kinds of stuffs, we call them as an object. So in computer paradigm, in our programming languages, we define a class first, then by using the features inside a class, we create an object, right? So that is the difference between an object and a class. Object is a real-time entity that takes the data in the form as we described in the class, and that does the things as we described in the same class. You can have as many objects to the class. Every object is still different to each other. They are not having, even though they are a part of the same class, they have different memory, and they are different peoples. They are not one and the same. And here is one of the most important question, what is the difference between a class and a structure? So many people are thinking that, sir, class structure is also doing the same thing. No, what is the need of class? So you need to understand a basic difference among structure and a class. See, structure is, it defines only the data. Your designs only the data. Okay, so of course you can design whatever the way you want. You can design the same ID card structure also. There is no problem on it. But you are not telling these are the features that you can perform on the data. These are the tasks that you can perform on the data. So you can create an ID, you can edit an ID, you can delete an ID, right? So these are the, let us, for an example, these are the three tasks that you can perform on the data. This is not specified in terms of structure. Structure is only, it is a data type, that's all. But class is more than a data type. You are defining how the blueprint of the object in terms of data. Okay, these are the data that we are having, and what are the tasks that can be performed on the data. We pack together both of the things, and then it will be called as a class. We are telling that these are the data that an ID have, and these are the methods. So these are the tasks that can be performed on the data. So both together. So what are the main features of an object-oriented programming that we have discussed already? What is all about inheritance, taking this as a base copy, and we can evolve our system model with respect to the changes that happening on day to day. and encapsulation, it protects it acts as the class acts as a layer of security to the data, and it restricts all the other peoples to access the data. So that is where the encapsulation comes into play. And polymorphism is something that writing the same code and it behaves differently with the different kinds of inputs and different types of input, different number of inputs. So even for example, I'm writing a code for sum of n numbers. You can write the code that deals with the string also for concatenation and with number also for addition. So with respect to the input you gave, it behaves differently. So this is called polymorphism. There is no need to write the same line again. And data abstraction, which means that by looking at by looking at the class structure itself, we are telling two things. So these are the things that an object have. If the particular object has to be a car, it needs to have four wheels, and the four wheel has to rotate, and there is a light, and there were some seats inside, that there should be a horn. So it describes the object, that's all. We are not telling anything beyond, we are not describing more than that. So we give only the abstract information about an object. So these are the things that you have. If a particular entity has these all the things, then it becomes an object to the class. So there we are supplying only the information that was only required and not beyond that. What is it? We never say how it is going to be implemented, right? So this is called data abstraction, and it is a real trick question actually. Difference between a procedural programming and OOPS, because Python can behave both ways. It can be a function oriented programming and it can be an object oriented programming as well. So it never enforces the programmer to start, you has to start a class. Like as in Java without a class you cannot write anything. So whatever thing you have to write inside a class only. So that is not the case with Python. You can build your script with only functions also, like as you did in C. So Python, it balances both kind of a people. So if you wanted to go with, if you're happy with relenting on functions, it is okay, you can go. Or else, no, I wanted some higher order level of programming, so I wanted some good stuff with some security, some additional features that I wanted to implement in my programming model. You can go with OOPS. So by using procedural oriented programming, we are our basic building blocks is functions. So we divide our entire task into so many subtasks, which is called divide and conquest strategy. Based on the divide and conquest strategy, for every subtask we will write a function, and we call the function accordingly to complete the task. That's all. So it is based upon as simple as that. And for object oriented programming, it is it also procedures, it also follows the same extent, the same procedure to some extent, but we are using a wrapper class as a class. So instead of functions, we would call the functions which is inside a class called as a method. If I call it as a method or a member function, that function is accessible only to the objects, to the objects of the particular class, which is not, you cannot call it by using the object of the next class. And you can have as many classes you want, you can have as many objects you want. So it gives us a freedom to organize things properly. Instead of put everything in a scrambled way, we can clearly organize. Okay, this is the class. You can speak about any vehicles. If you have class, if you go with object oriented programming languages, it is very easy to spot what kind of a vehicle it is by looking at the features and classes itself. But it is very difficult in terms of procedural oriented programming. So if your programming nature it is not that complicated, it is very simple, you can go with procedural oriented programming because it is very simple and straightforward. No, if it deals with more number of people, more number of entities, everyone is having different kinds of properties, everyone is doing different things, but you need to track of all those things. If it is a bit complicated, it is always better to go with object oriented approach. So, and what is inheritance? We have discussed enough about inheritance as of now itself. Coming back to one more explanation, you can take this as another explanation. Inheritance is the ability of using the code again and again. So you just take an example, the same vehicle. You, in olden days, the vehicle started with walking. Only people used to walk, and next they used to impart animals, and next they invented wheels, one of the most uh, useful invention in the mankind, the history of mankind, wheels. And after the wheels came into existence, we used animals and wheels together. And later on, we replaced animals with some mechanical parts. So then we cycle came into existence. Then we replaced the mechanical force with some automated forces like some fuels. Like then engine came into play, and today electric cars also comes into play, so still it is vehicle. The motive of vehicle is to move from one place to another place. That's all. Even today, whatever the vehicle is speaking about, that does the same task, that does the same job now. But you see how the vehicles has been transformed from walking to the electric vehicle. See, it evolves so much, right? If you are not using an object-oriented programming, you have to write code for every evolution right from the scratch. So this is not something. It is something absurd. And if you are using some object-oriented language, we can have the current copy as a base copy, and we have built on it. So might have handlebar. You just take an example of handlebar. Does different things in all those places. And belts, there are different types of belts, lights, seats, pedals. The pedals is are also present in cycle and as well as in motorbike, but they have two different functions. They are not the same, right? So sometimes we used to carry the same feature, but that performs differently, right? So for these and all, there is no need to write a program code right from the first. It is enough to stick on with the code we have, and we need to build on it. And this is called inheritance. This process is called inheritance, the process of using the base model and to build on the new features onto which, and this process is called inheritance. So what are the different types of inheritance you are dealing with? Single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, hybrid inheritance. This is the same kind of inheritance we are dealing with C++ or Java. So he has to go and deal with what are the types of inheritance, what it is dealing with in detail. Single inheritance means you are taking extract of only one class. Multiple inheritance, we are dealing with so many classes. Let's take 4 or 5 base classes, and from 4 or 5 classes I take an extract, and a new class will be derived. So this derived class has a trace of all those 5 classes. This is called multiple inheritance. Multi-level inheritance, this is what more commonly we are using. Multi-level inheritance is we are maybe there is a one base class onto which we have derived a derived class 1. From the derived class 1, so you build on again, you develop with derived class 2, 3, and it goes on. And hybrid inheritance is something that whenever we are dealing with more than one types of inheritance, so yes, that is called as hybrid inheritance. And hybrid inheritance is the most common form of inheritance we are using in industry, because whenever we wanted to inspire something, so that is a new base class again. And the model we have right now in the hand is not the new model, that is not incepted yesterday. It has been derived from the older model, so it will be a multi-level inheritance on your hand. On the other hand, so we look at something and we got inspired something, and now we are putting the future onto our things, and it becomes a hybrid inheritance, right? So these are the difference between inheritance. And what do you mean by polymorphism? Poly contains two words, poly and morphs. Poly means many, morphism means shape, actually different types of behavior. As I said, you just take an example of addition of two entities, addition of two objects, addition of two different things. Okay, now we are going to play on with the two different things. What are the things? If the two different things are numbers, we simply add them. Okay, and if two entities or strings, we simply concatenate them. We put together as a same string. So now the plus works as a concatenation. And if it is a two different list, what it will do now, it will combine both the list together, and it will return you on another list. So the same function that behaves differently with the different kinds of inputs. So this is called polymorphism. One of the striking features of the object oriented feature is its encapsulation. Encapsulation means in general we put together the code and the methods as a single unit, so that will not be tampered by any of the other people who was next or outside of the class. No one knows what is there inside a class. So it is like a simply locked room. Whatever you wanted to put inside a safe, that is safe inside the room. So only the people who is having a key will open the room and come inside. The key is called object. Only the objects which of that particular class can open the room and come inside and call the methods. And object also cannot allow, is not allowed to fetch any of the things directly. It is a good practice that you call the method. That method will in turn call, go and fetch, okay, these are the things you wanted, okay, these are the things data I have, that will give the copy of the data by as a return value, right? So this is a good practice to follow. Don't try to access any data, any kind of data which is stored inside a class by using an object. You always use through the method. So this protects the data to a greater extent. So no one knows the data which is what is present inside a class. So if no one is aware what is present inside, obviously they will not tamper it. But again, the room is locked with a key. Only my object will come inside, and that too every object has a different memory. See, for example, I'm having a single, we both peoples have a locker, have a safe inside a same room. Okay, whatever things I did in my locker doesn't reflected on you. Even though I take a data and I do delete it, but I trash the data becomes zero. I rewrite all the data becomes zero, okay, as zero. So that zero will be saved in my memory only, that will not reflect other people's. So that is the kind of a security that an object oriented program offers us, and this is called encapsulation. So what do you mean by access specifiers in any object oriented programming language? So object oriented programming language is something that it offers you an encapsulation, it offers you inheritance, it offers you polymorphism only by wrapping up of the data and methods inside a single unit. That is achieved by that only, right? So what is all about access specifier, where it comes into play? So in terms of inheritance, I'm going to take the base copy, the current version of the class as a base copy, and I'm going to build on it. So what will be there in the new class which I am derived? Whatever present inside the base class already in my current version will be there in the derived version also. No sir, I don't want to give anything, all the things to the people who wanted to derive. I wanted to have some restriction. So I need to specify, I need to tell to the compiler, to the interpreter that, oh, no, I don't want to share this particular thing. This is something which is very private to me, and I don't want to share this method or data to the other peoples, even in inheritance also. So the most common access specifiers used in Python are public, private, and protected. As we are doing looking, this is the same kind of an access specifier which is there in Java and C++ as well. Okay, let us see what is that in a while. So now you can see clearly the difference between a public, private, and protected access modifiers. So now I'm going to inherit a class B from a class A. So class A is our base class and class B is the derived class. Okay. Now, if there were public data members and functions, if I made it public, then there is no restriction on them. So whoever can derive, the same thing will be reflected in the new derived class also. So there you can see in the first line, if all the public members will be defaultly derived into the derived class, so which is open to the outside members also. Anyone who wanted to carry to deal with that, you can also by using the objects. Of course, by using the objects you can deal with. Next is private, which is contrary. So if I protected a member called some data, for example phone number, under private, so this private member can be accessed inside my class where I declare those variables, the base class, that will be accessible. All the private members will be accessible inside my class. But when I derive from this base class, these private members will not be inherited to the derived class. It will be there inside only my class only. It will not be shared with anyone else. So obviously it is not there in derived class, so you cannot access it from the outside also. And protected. See, protected is something that it is a mixture of both of them, public and private, but in a certain way it acts as a public, and in certain way it acts as a private also. Uh, Whatever the data members or methods which is specified as a protected, we can use it inside a class, inside its own class, like public and private. Both of the members, whatever the members, you can declare it as a public or private, we can access inside a class. Similarly, protected also you can access inside the base class. But what happens when you are about to derive? Private members will not be derived. Public members will be defaulted derived. Protected members will be derived as a protected members only. Again, in that class also, it will be in the same protected mode. You can access inside the class only, but which will not be separate, which will not be accessible to outside of the world. No, you cannot use any other method or anything to call it. So this is the difference between public, private, and protected. So one simple tip I can give you is that you can always put your data as either, most of the cases, try to be put it in public or protected mode. In some cases if you want an extra security has to be done on the particular data, you can go with the private mode, because whenever you are using private mode, it is exclusive to that particular version of the class, and which will not be derived in the future. It will not be able to use those data. So you have to be very careful that whenever you are giving some data as private.